What's up mga Kakasha Nation, and this is Engineer JD. So mga nas videos natin, so discuss tayo about sa introduction dito sa Casio FX 991 MS model natin. We were able to discuss yung basic calculation features niya and then the solving equations part natin. So today, ang di-discuss natin ngayon ay yung dalawang most important operations sa calculus, which is the derivatives and the integrals. Okay, so let's get through it. So ito na, tara. So ang una natin i-discuss ngayon, so between derivatives and integrals. So unahin ko muna yung integrals. So why integrals? No? Because dito sa calculator natin, so you only need to remember yung sum key, no, to calculus natin. So we have this. So this is, ito lang yung tatandaan ninyo yung key. So the first key, if we press this key, will pupunta tayo sa integrals automatically. And if we press shift and then this key, doon tayo pupunta sa derivatives natin. Because integral is yung first most accessible dito. So we'll first do the integral. So sa mga bago sa calculus, no, so introduce natin in the most simplest way, no? In the simplest way, ano nga ba yung integrals natin? So ano ba yung integrals? For example, di ba, meron tayong matatandaan nyo sa elementary math natin, tinuruan tayo paano mag-calculate ng areas ng figures, no? Like area ng rectangle, area ng circle, area ng triangle, so on and so forth. No? And we applied yung mga areas technique natin para makapag-calculate ng more complex shapes natin. For example, like this one. So, gagawin lang natin, i-divide natin siya into 2, di ba? So, some semicircle, and then some square or rectangle, and then add up the areas na makukuha natin. So, gano'n natin siya kinukuha yung mga shapes. But what if example, binigyan kayo ng isang very irregularly shaped na figure. For example, ito, we have a random figure, a random shape right here. And tinanong sa inyo, ano yung area nitong shape na to? So, isip pa kayo, paano ba i-calculate ito eh? Paano ko ba i-divide ito? Paano ko ba i-calculate yung area nito eh? Parang wala ka namang way para i-divide siya into something, no? So, ganun yung mga nasa isip mo. Pero, sakali yun pero actually, pwede mo pa rin siyang makuha na ng area. So, how do you do this? No? So, in general, pwede mong gawin, so divide mo siya pag ganito, for example, so and then divide mo ulit siya ng pag ganito, so yan, so divide mo pa siya dito, so on and so forth, hanggang sa ma-divide mo lahat yan into those types of shapes. So itong shape na to, no, so kukuha tayo ng isa dyan. So, ang tawag natin dyan ay strips. Strips or gusto nyo, french fries. Okay. So, itong french fries na to, so, didivide nyo yung shape na to into several french fries. For example, no? Now, itong french fries na to, sobrang nipis niya, no? Sobrang liit ng width. Kumbaga yung width nito, kung gaano kalapad to, approaches yung 0. So, maliit siya na maliit, pero hindi siya 0. Hindi mo imagine yun. Maliit na maliit, pero hindi 0. So, sa maliit na yan, tapos 0 siya, no? Hindi siya 0, pero maliit na maliit siya. So, pag zoom in nyo yan, ang makikita nyo, somewhere like this one, parang ganito. Yan. So, pag zoom in nyo siya, ang mangyayari, yung sides niya, no? So, of course, alam natin, ito sa akin ito, irregularly shape yung curve natin dyan. No? Pero pag zoom in nyo siya, para siyang straight yung tsura. So, para siyang straight na magiging mangyayari, itong strip na to, para siyang rectangle lalabas sa kanya. No? So, alam natin syempre, paano natin i-calculate yung area ng rectangle, diba? That's base times height. Okay? So, base times height. So, that's the area of the strip. No? So that's the approximate area of this strip. Kasi approximate, dahil in-approximate natin to as parang straight siya, na parang siyang rectangle. Now, we add these areas, no? Marami tayong French fries na ginawa. I-add up natin yung areas ng lahat na yun. And that's the approximate area of the entire shape natin. No? And to get the total area, yung exact area ng figure natin, we make yung width nito, yung nipis nito, make it smaller and smaller hanggang sa sobrang lapit niya na sa zero. And then, pag ganun yung nangyari, so ma-approximate niya na, ma-approach na yung true shape ng original figure natin. And that will become approaching yung total area ng shape natin. So that's yung pag-sum up ng areas na to, no? Pag-divide into shapes, pag-sum ng areas. Ito yung concept ito yung simplest concept ng integral natin. So integrals, so are usually denoted by this symbol. Ayan, so symbol, then f of x dx. So we have f of x, that is a function. So usually it is defined between two numbers, no? So a and b, no? So a is the lower bound, no? And b is the upper bound. And what do you mean by this one? So we have a graph, diba? So graph called f of x. So divide natin a, then this is b, no? So ang sinasabi ng integral na to, no? So integral from a to b of f of x dx is just the area of this figure. So area under the curve of this figure. Yeah. So that's how we simply define yung integral na to. So hindi ko na i-describe yung very mathematical definition nito. We try to make this as simple as possible. So, how do we calculate integrals? So, paano natin i-calculate exactly yung mga integrals na to? So, si Casio FX991ES, so kinakalculate niya yan using yung tinatawag na Simpson's one-third rule. So, we have yung marami tayong numerical approximation methods dito. And Casio FX991MS employs yung tinatawag na Simpson's one-third rule. So, Simpson's one-third rule goes like this. So, for example, meron tayong function dito, tapos define siya dito, a, b. Ang gusto natin, di ba, if we try to get the integral of this function from a to b, we are to get yung area between these two x, no? To x equals a, tsaka x equals b. Now, Simpson's one-third rule, ang ginagawa niya, so, i-divide niya, for example, into one region to. Yan, so itong region na to, so divide natin siya. Itong region na to is the midpoint of A and B. So, midpoint ng A and B, so this is A plus B over 2. So, average siya. Ayan. And then, what this rule does is, kinukuha niya yung 3 points doon sa function, and then i-approximate niya using a parabola. Yan. So, it does a quadratic approximation. So, i-approximate niya using parabola. And therefore, ang i-calculate niya ng area is ito, yung bounded na itong parabola na ito. So, this is our approximation. So, the area that it will calculate is this one. Yan. Itong parabola. Yan. So, ito na i-calculate niya hanggang dito. Now, kung gusto nyo ng mas approximate, kung gusto nyo mas, of course, nakikita nyo, may error yan. No? So, may introduce kang error dyan because may discrepancy between yung exact function at yung approximation natin. So, to reduce this error, ang ginagawa natin, we can add additional points dun sa function natin. Yan, for example, yan. And then, approximate them into separate quadratic approximation. So, for example, yung first 3 points, so ito yung una. So, first 3 points, ito yung approximation natin. And then second, yung next 3 points natin, so ganito yung approximation, for example, yan. And then for each 3-point approximation, kukunan nyo ng area using Simpson's one-third rule. So, ganyan siya. So, ganyan kinakalculate ni Casio yung integrals natin. So mathematically, so di ko na ipapakita yung derivation nito because it's sobrang tagal. No? Pero kung gusto nyo, I'll show you yung alam kong approximation at the end of this video. So, in short, ang pag-calculate ni Casio ng integral is using this formula. So, the integral, so denoted by A, no? The area under the curve is equal to h over 3 times f of A plus f of 4 times f of A plus h plus f of A plus h. Ayan. So, ganyan na kinakalculate yan. Where h, no? Where h is b minus a divided by kung ilan yung number of divisions natin. So, basically, kumbaga, h is the width, no? Kung gaano kalapad yung strip na pagkukunan nyo. So, this is h. For example, okay, h natin. Now, syempre, this is just for 3 points, no? So, 3-point approximation lang yan. Pero for maximum accuracy, kailangan natin ng more points possible dito. So, pag more points ang mangyayari, magsa-stack up yung mga equation, yung mga terms natin dyan. Hanggang sa mabuo niya yung entire formula for calculating the integral. So what this formula means is, halimbawa, calculate ka dito, so from A to B. So divide ko siya into 3 points. Ayan, divide ko siya for example dito. So itong first 3 points na to, no? So ang coefficients ay 1, 4, 1. Tama? So nakikita ninyo, 1, 4, 1 yung coefficients natin. So 1, 4, 1. So whatever yung nakuha nating value ng function dito, so ito times nyo ng 1 yung una, then yung sunod, ito times nyo ng 4. Then yung sunod, ito times nyo ng 1. Okay? So ganun yung mangyayari. Then, next 3-point approximation, so ito naman yan. So, next 3 points. So ganun ulit, same formula. So 1, 4, 1. So again, itong first term, so 1, then yung second term, 4, then yung third term, 1. Okay? Then and so on and so forth hanggang sa makarating kayo sa dulo ng integral natin. So if we add those, expressions, so makakakuha kayo ng pattern na 1, 4, 2, 4, 2, and so on, then 4, 1. Ganyang pattern yung makukuha ninyo. Then, times nyo ng h over 3 sa labas. So ganyan kinakalculate ni Casio calculator yung integrals using the Simpson's 1/3 rule. Okay, so now kapakita ko na yung concept, so I'll show you an example. So paano ba kinakalculate niya? So example natin. So meron tayong sphere. So meron tayong sphere. Then yeah, so dito. So ang radius daw ng sphere natin is 1 meter. Then yung height nito is 0.4 meters. Itong shading area. So kumbaga, meron kang orange, kinat mo dito. So kinat mo horizontally, tapos kinuha nyo yung taas. Yan. So ang height daw ay 4.4 and then 1 meter yung radius ng circle. So pinapahanap sa atin yung volume nitong, so ano yung volume nitong circle na to? Ano yung volume nitong part na to ng sphere? So, by the way, ang tawag dito is the zone of the sphere. So, zone of the sphere, no? In this case, of one base, kasi isa lang yung base niya. Ito lang yung base. So, paano ba i-calculate ito, no? So, if you are familiar, no? So, kung alam niyo yung formula for the area of zone of one base, no? So, malalaman niyo agad kung ano yung sagot natin. So, the volume of, so pakita muna natin, no? So, as I recall dun sa previous videos natin, so, yung zone of one base as a volume of 1/3 pi h squared times dr minus h. Ayan. So, ito yung formula where h is the height of the zone and r is the radius of the sphere corresponding to that zone. No? So if we substitute to the formula, no, so pakita na natin. So we have 1/3 times pi, and pi, so shift pi, so times 10 to the x, so pi times h squared. So h natin is 0.4 squared times 3 times radius of the sphere 1 minus h, so which is 0.4 again. So the volume of the sphere is 0.4356 cubic meters. So this is a recall dun sa second video natin. So if you were able to do this correctly on your own, then congratulations at na-master nyo na yung second video natin. So that's how we calculate directly yung volume of the zone. No? But what if hindi nyo alam tong formula na to? So paano ba natin i-calculate yung volume nito? So doon papasok yung tinatawag na integral calculus natin. So doon papasok yung integrals natin sa part na yan. So let's draw again. Yeah, ito lang muna. So I'm gonna set muna this axis, this is our x-axis. This axis, pataas. This is the z-axis. And then, since ang radius ng sphere natin is 1, so this point right here corresponds to 1, z equals 1. And this is origin, and this is x equals 1. So, sineset up natin siya as coordinate system lang. No? Then, we have a height of 0.4. So, meron tayong height of 0.4 dito, 0.4 meters. So, therefore, pababa, so this point corresponds to, this is 1, this is 0.4, so this is 0.6 meters. So, 0.6 meters. Ayan. So, meaning, 0.6 to, plus ito 1. So, tandaan niyo yan, no? So, 0.6 to, plus ito 1. So, now, i-cut natin yung, cut mo vertical itong sphere natin. So, ang makikita nyo na lang is ganito. No? So, cut natin yung center. So, kinat nyo siya dito. Yan. So, this is 0.4. So, based on calculations, 0.4. And this is 0.6. Now, gagawin natin, so pag nag-set tayo ng arbitrary na, diba? Nag-set tayo ng arbitrary na segment dito. So, anong corresponding niyan dyan? So, ang corresponding niyan dyan is para kang nag-cut dito. No? So, nag-cut ka dito ng horizontal dito. So, yan. Yan. So, kumbaga, nag-slice ka ng maliit dito. So, nangyari, nag-slice ka ng maliit dito, so nagkaroon ka ng parang disc, ng manipis na disc dito. So the radius of this, so small r, is still unknown to us. Ayan, hindi pa natin alam yan. So corresponding to this one, the radius of this is still unknown to us. Paano natin i-calculate ngayon yung radius na yan? So paano natin i-relate? So now, let's let this distance papunta dun sa gitna be z. So, this is natural kasi naka-z-axis tayo pataas. So, this is z. And this one, dito pala. This one is 1 meter. Kasi alam natin, the radius of the sphere is 1 meter. So, this is a right triangle. And we have a right triangle here. So, by the Pythagorean theorem, so meron tayong r squared plus z squared equals 1 squared. So, 1 meter squared. And then solving for r in terms of z. So we have r equals the square root of 1 minus z squared. So meaning, the radius of this disc, yung kinat out natin, is related dun sa distance niya from the center by square root of 1 minus z squared. And now, matatandaan natin dun sa definition ng integral natin, yung cut many, so ikakat nyo ng marami, na maraming strips. ng mga maraming disk, no? And then you add up those disk, no? Kung ano man yung kailangan yung i-add up para makuha natin yung area or volume for this case. Now, alam na natin yung radius nung kinat out natin, no? So, next question is, ano yung volume nung kinat out natin dito? So, yung kinat out natin, sabi ko nung kanina, sobrang nipis niya, na sobrang liit niya, close to zero, pero malapit siya sa zero. Pero hindi siya zero. So we denote it, since nasa z-axis tayo, so we denote it with z, pero to indicate na manipis siya, so we write d sa harap. So d meaning differential. Yan. So dz is the thickness of this disk. So therefore, the volume, what is the volume of this disk? So, to indicate na yung volume of this disk is because manipis siya na malapit sa zero, we write D in front of this, the volume of the disk. Now, this disk approximates, of course, a cylinder. Tama? So, para straight yung sides niya na para siyang cylinder. And alam natin yung formula ng cylinder is pi r squared h. So this is the formula for the volume of the cylinder. So sulat natin. So pi, the radius of this is square root of 1 minus z squared times the height h, no? Which is yung thickness ng disk natin, which is dz. Okay. So simplifying, we have pi times 1 minus z squared dz. So this is the volume of this disk, no? Yung maliit na to. Yeah, this is the volume. Okay? Now, so ito na yung volume ng disk natin. So let's recall. So dV is 1 minus z squared pi. Now, given this, paano natin makukuha ngayon yung volume ng buong zone natin? So sabi ko kanina, to get the total area, we need to add up those tiny pieces of areas natin, or volumes for this case. So, we do the integral. So, integral of the volume, so gives us the total volume of this one. So, integral, in this case, sabi ko kanina, this one is 0.6 and this one is 1. So, the lower bound is 0.6, the upper bound is 1, and then sulat natin, so dV is pi 1 minus z squared dz. So this right here is the integral na kailangan nating i-input to. So input na natin ngayon dito, no? So we have integral from 0.6 to 1, but hindi yan yung sequence natin. We'll start with the integral first, no? So integral of pi times 1 minus x squared. So that's the integrand. Then press comma, ito yon. So yung comma, yan. Then the bounds are from 0.6 to 1. So lower bound muna, 0.6, comma, and then 1, comma. Now, para saan itong additional number natin? So Casio, so the integral algorithm of Casio FX991MS adds a fourth number, no, called n. So n indicates, so kumbaga, it is an indicator of the number of slices, number of partitions na gagawin nyo sa ano natin, na gagawin ninyo doon sa shape para makuha nyo yung area or yung volume. So the larger the number, the more slices that we will consider. And yun, so the more the slices, so the larger the number, the more slices that we have. So the advantage is that it is more accurate. So the accuracy is higher, but the downside is that the time to calculate it is longer. Yun yung mangyayari. Now, if we reduce the number of slices or reduce that number, so the slices will become smaller in number, and it will decrease in accuracy. So to say, but the advantage is mabilis siyang i-calculate. So it's higher in time. So when using this integral operator, you need to balance between accuracy and time pagdating dito. So the fourth number can go from numbers 1 to 9. So ito lang yung range niya, number 1 to 9. So beyond that, error na siya dun sa calculate natin. So usually I use 5. No? So 5 as the recommended number. No? So it gives you the enough accuracy for computations, and its time to calculate is enough para makapaghintay tayo. So let's press 5. Ayan. So it gets this answer. So the answer is 0.4356 34181. So this is the correct answer. So using the Casio calculators. Now, you want to experiment. So what if we change it to any number na alam natin? So palitan natin ng variable a. So then press calc. So sabihin natin 1. So dito 0.4. So 0.4 lang kasi 0.4 lang because what Casio does, no? So what this calculator does is i-calculate niya using Simpson's one-third rule yung integral, and then kung alin lang yung tama, kung alin lang yung correct lang yung decimal places. For example, example ito 0.4, ito lang yung tama sa kanya, the rest of the digits are wrong. So ibig sabihin, ika-cut off niya na doon sa decimal place na yan, and yung tama lang yung i-display niya. So in this case 0.4, so meaning it's only accurate to one decimal place, kaya naging 0.4 siya, no? So if we change, for example, gawin natin 2, so nag-display na siya dito 0.435634181. So meaning it's accurate sa lahat ng decimal places na naka-display dyan, tama? So ganun yun. Ito. So I hope nakuha naman yung concept na yun. So two things you need to remember pagdating sa Simpson's one-third rule, pagdating sa pag-set ng number of partitions, is that if your integrand is quadratic in nature, no? For example, if your integral is, for example, integral of x per dx, and you set yung fourth number natin, for example, 2 or pataas, fourth number, then you will always get the exact answer, because the reason being, Simpson's one-third rule is parabolic in approximation, and this is already a parabola. Tama? So automatically exact na yung sagot niya. So ganun. Now, pag umangat ka pa, x cubed dx, for example, yan. So pag umangat ka pa, dito approximate na yung magiging sagot na, because this one is not parabolic. So hindi na siya parabolic, hindi na siya second degree. So approximate na yung bibigay niya sagot. So yun yung 2 points to consider, no, para sa accuracy ng integral. So I hope may nakuha kayo dito, no? So now, let's go to the second operator natin, which is the derivatives. So derivatives, no? So on derivatives, on the other hand, ang ginagawa ng derivatives in the simplest way possible is this. Yes. For example, meron kang graph, no? So meron kang graph. And then, for example, gusto kong meron dito, no? So meron ka dito. Gusto kong kunin yung, ayan, so meron tayong point dyan. No? So meron tayong point dyan. Pag zinoomin natin yan, zoomin ko, no? So pag zinoomin natin yan, so you get something like this. Ayan. So zoomin ko. Then zoom in pa natin ulit. So you'll get this one. Yan. And then zoom in ko pa ulit. So ang makuha natin ngayon is so dito may kita ninyo. So from this point papunta dito, no? So we take yung viewing point, yung viewing area natin, smaller and smaller, no? Hanggang pagdating sa point na to, around this point, so around this point na kino-consider natin, straight line na siya dyan. So para na siyang straight line yung itsura niya. So, and it's typical for all types of graphs. No? So, pag liitan nyo na liitan, pero hindi yung zero na talaga. So, ito, magiging straight line na siya. Now, if you get the slope of this, so yung slope of this line, so approximate line natin. So, this is what we call the derivative of the function at that point. So, ito yung derivative. So, mathematically, kinocompute natin yung derivative na as derivative. So, symbolized by f prime of x or dy over dx. Naman dyan. So, equals. So, equal siya. So, the limit as h approaches 0, f of a plus h minus f of a over h. So, syempre, unless sobrang advanced na ng features ng calculate yung advanced na yung features ng software or yung code natin. So, actually, it's impossible na makalculate exactly yung limit ng function. So, what Casio FX911 and 991MS does is to approximate it by not taking the limit, no? But, to actually take this value of h, no? And then make this value of h approach 0. So, papalitin nyo ng papalitin yung h hanggang sa maging 0 siya. Yun yung gagawin niya. So, this is the same concept as yung papalitin natin yung zooming view, no? So, yung zooming view na to, ayan. So, kumbaga, yung height ng zooming area natin is h. Ano? Then, yung h, papalitin nyo siya ng papalitin. This is the same concept na gagawin natin. So, that is why, in 991MS, it requires 3 functions. No? So, we have d over dx. So, we have 3 functions for that. So, first is the function na i-differentiate ninyo. Then, so, next is kung saang value nyo siya i-evaluate. No? So, around what point? No? Around what value of x. And then, the tolerance value natin. Or, kung gaano kaliit yung h. So, basically, this is h. Kung gaano nyo siya kaliit, i-define. So, example, for example, we have y equals x squared. Ayan. So, we want to find the slope of this around, example, around x equals 2. We want to find the slope of this around x equals 2. So, so para makalculate natin yan, so first, we shift and then ddx. Okay, shift integral, input the function x squared, then at x equals 2, so input 2, and then what is the value of h? Ano yung magiging tiny increment natin dito? So, say 0.0001, so say ganyan kaliit, so it calculates to 4. So the value of the derivative is 4. So which we can verify correctly, no? Because y prime, so the derivative is equal to 2x, tama? The derivative. And then substitute 2, so times 2 is equal to 4. So that is the derivative. Now, experiment nyo maigi to. So what if we use larger value? We use larger value of h, for example, 1, 4 pa rin, no? 5, 4 pa rin. So actually, pag polynomials like this one, almost exact yung pag-calculate. But what if try natin 1 over x, ayan, 2, then hindi natin, so a natin, calc 1, so ito, so what we are trying to calculate here now is the derivative of 1 over x at x equals 2. Ayan, so derivative of this is negative 1 over x squared. So substitute 2, so negative 1 over 2 squared, making negative 1 over 4. Ayan. So ito, So, ang exact value niya is negative 0.25. Ayan. So, negative 0.25. So, dito, ang naging value niya is negative 0.2499999608 for the value of A equals 1. Increment H is 1. So, pag dilitan natin yung value ng increment, so A is 0.5 for example, so lumalapit siya, no? So, nakikita nyo, lumalapit siya ng lumalapit doon sa exact value niya. Okay? So, litan pa natin. Ayan. Ayan. So, diba? Oops. Ayan. So, hanggang sa so, 0.25. Hanggang sa ma-achieve niya na yung required accuracy niya na point. So, 0.25 dito. I suggest, no? So, any value of the increment will do, no? So, pero for me, no, I use this h equals 0.001. No? So, it gives accurate value of the derivative, no, for all purposes na kailangan natin. So, you don't need very accurate ones, no? Kasi ang kailangan nyo lang is yung tama lang. So, this gives you the best accuracy, no, at the shortest computation time possible. Ayan. So, that's for the derivative natin. Ayan. And that ends, no, yung discussion natin for derivatives and integrals. No? So, may mga natutunan ba kayo today, no, mga Kakasha Nation? So, if meron, so you can comment on the comments. You can post it on the comments page, no, and we'll read it and appreciate namin na may natutunan talaga kayo dito sa video na. So, again, this is Engineer JD and I'll see you on the next video, which is yung calculation na natin on statistics natin. So, again, see you!